Hello everyone. In the quiz, the second problem, I didn't cover an exactly similar problem in class. So in this short video, I'm going to show you how to use the property the gradient vector is orthogonal to the level surface to solve the second one. To begin with, let's recall together what's the property of the gradient vector. So if the function depends on three variables, so here's my function, then the gradient vector is going to orthogonal to the tangent plane to the level surface passing through the point x, y, z. So here is the picture. Let's look at this picture together. This orange surface is the level surface of the function f. And this green plane is the tangent plane to this level surface at this point P. The property says if you calculate the gradient vector of f, evaluate it at P, this is vector, the gradient vector, it's this one. It's going to orthogonal to this green tangent plane. Or in other words, you can see that this gradient vector is actually can be served as the normal vector of this green tangent plane. Now let's look at this example, which is similar to the quiz problem. So I want to find a point on the saddle so that the tangent plane there is parallel to a given plane. Here is an illustration picture. So that's not very accurate, but I'm assuming this is a saddle. So I'm looking for this point P, and the tangent plane to the saddle at this point is this gray plane. It's parallel to this given blue plane. So that's parallel symbol. It's easy to figure out this N2 and N1, which are the normal vectors, must be parallel since the planes are parallel. And this vector is the normal vector to the given plane. You just collect the coefficients. The difficult thing is how can you find the normal vector to the tangent plane of this given saddle at this point. It's time for us to use the property of the gradient. We can rewrite the saddle equation in it's easy for us to rewrite the saddle equation in terms of a level surface. You just put all term on one side and leave 0 on the other side. Then you can call the left-hand side function, you call it f, therefore this saddle becomes the level surface of this new function f. And by calculate the gradient of f, it tells you a vector. The gradient vector tells you the normal vector to the tangent plane. So what's left is you can move on to calculate the gradient, collect the three partial derivatives. You have 2x minus 2y and minus 1. And that's the normal N1. So to make sure these two vectors are parallel, you just set them equal, the ratio equal. You can find x, y, which are the x, y coordinates of this point P, and then you move on to use the equation find z. So here's the solution. By letting these two normal vectors parallel, you solve that's the x, y value. And as I said, that's the x, y coordinates of P. P is on the saddle, so z can be calculated by x squared minus y squared. And altogether, that's the point on the saddle. And we know now the tangent plane to the saddle at this point is parallel to the given plane.